you should be good. Okay, so okay, so now everybody go ahead and connect to your server 1, and then we'll work on directory permissions. So far we worked on file permissions, right? Now we're going to work on directory permissions. So if you do ls here, you should still have file 1 and file 2. Oh, sorry, I'm supposed to connect to my server here. So I'm connecting to my own server here, and there is no files or directories in here, right? So what I'm going to do is, let's create a directory. So can somebody help me? What is the command to create a directory?
mkdir.
Yes, very good. mkdir, and I'm going to give the name dir1. Okay, and what I'll do is okay, so directory permissions. So I created a file called mkdir, and then I'm going to do is ls-l, right? ls-l, and hit enter. So this is what is going to come out of the directory here. So okay, before that, let me see if we were working. Okay, so go ahead and switch as a root here. We are logged in as a user. Don't worry about that. So go ahead and switch as a root. sudo su hyphen. Let me just remove everything here, what I have. sudo hyphen and hit enter. And I'm going to give my password. I thought I was in wheel group. Okay, yeah, it does still ask for the password, I guess. So I did have my previous file one, right? So what I'm going to do is I'm going to create a directory mkdir dir1, okay, and do ls hyphen l, ls hyphen l. So this is okay, I'm gonna get rid of file one here because it's gonna interrupt when I'm gonna rm hyphen rf. File one is gone. So just create mkdir and you do clear and you do ls hyphen l. Okay, so what is going to happen here is we see a little bit different here. The permissions granted by the directory and the permissions granted to the file is a little bit different here. Okay, so what we're gonna do is we'll work to take a look on this here. Why is this so? So I'm going to copy this part here and paste it here. And I'm going to make it bigger.
Mr. Zafar, is the recording on?
I'm sorry? Yeah, recording is on. Did you hear me? Yeah, recording is on. Okay, so what we have here is this is one part, read, write, execute here. So let me see what color I gave up here. Okay, so yellow, blue, and green. Okay, what the color I colored it, whose permissions are those? Those permissions are for the anybody? First set
and others.
No, the group, the first group is, who is first group? The yellow.
User.
Yes. Who is middle?
Owner.
No, user. Then comes the group.
Oh yes, right, group.
And then the last one is others. Okay. Okay, so here you see D here, right? Earlier I explained you D is just the indication it's a directory. Okay, so D is there, and so we're gonna work on looking at the permissions here. So let's take a look at permissions. So we have 9 again. So literally I could copy from top here the permissions, then we'll change around and I'll explain you. Okay, so it's the same exact concept. U is users is read, write, execute, and in this case everybody has full permissions here. If R is there, that means number 4 is active. Write W is there, that means 2 is active. Execute is X is active. So I'm gonna give 1 here. Okay, and then let's go to the group. Read is active, write is not active, execute is active. Okay, and then here the same thing, read and execute is active. So I'm going to just give number 1 here. Okay, so what is happening here is I explained to you earlier, so let me go back and grab this table here. So this is informational, this part here. Okay, this part is informational here. Maximum permissions anybody could have is this. Okay, so let's take a look here. The default directory permissions would be what? So let's take a look here. So in here, what is the user's permissions here? What are the total users permissions?
7.
Okay, yeah, 7. And group?
5.
Yeah, very good. Okay, so user read, write, execute, right? So it's coming up to 7. And group is read and execute. Okay, and the total is 5. And others is read and execute also. So this is 5. So the default directory permissions is 5. 755. Okay. Are you still with me? So the default directory permissions is 5 years. So why is it 755 and why not the default directory, the file was 644, correct? So here, the numeric permissions for our 644 is default. So what I'm going to do is I'm going to make one correction here. 644 is this is default file permissions. And here numeric permissions for our file is 755. dir1. This is the default directory permission. Okay, so I'm going to explain you why is it default permissions here. So let me show you the reason directory is having more permissions value compared to the file is simple here. I'll show you why. So what happens is so this part here, let me check my pen. So everybody knows this part is D stands for directory. Okay. Let me do this here. Okay. So I think I already mentioned this. This part indicates it's a directory. Oh, God. Okay. And this part is user. This part is group. And this part is other. Okay, so now what I'm going to do is but the biggest question is Y755, right? So if you take a look here, all of them got X permissions here. X equal to 1 equal to execute, right? So for the directory, what does the execute means? That means execute means going in the directory sense. Execute means going inside the directory. For the directory to be able to navigatable to go inside the directory, you should have execute permissions. So for example, if you have a room, right? There's a room and there is a door, you want to go in there. Okay, so think of this as a dir1. And if a user want to go into the door, he has the authority to open the door. Correct? So a user, to go inside the directory, a user should be able to have the authority to go inside the door, is called execute. Going inside the directory needs execute permission. Okay, and in this case, everybody has execute permissions. Okay, that's how the default directory permissions work. Okay, any questions? Now I'm going to give a 2-minute pause here, and I want to know if anybody has any questions.
Can we change these
Permissions?
things change the permissions when you are in regular, when you're a regular user, or you can do it only when you're a root user?
Oh, that's a very good question. So whoever is, if you have this permissions here, you could have this execute permissions here, but also you have to see who's the owner here. So that is coming up pretty soon. All these things matters here. If in this case only the root is able to change the permissions, which is because he is the owner. Okay, that's a good question here. So So what I'm gonna do is I'm gonna bring this down here, and so at this moment only the root user has the execute permission to change the permissions for the directory. Okay, so all right, so that's it here. So now we'll take a step forward, and then we'll understand more things which is going on in here. So let me copy this. Okay, so let's play around with this dir now. So actually, what we'll do is if we change this directory here, the regular user can't get in here, right? So everybody, let's create a directory in a root directory. Everybody go to like cd/cd, then just a slash, and hit enter there. And if you do ls here, you will see these are the system directories, right? So here, make a directory mkdir called test, test1, and hit enter. And if you do ls-l d, do ls-ld for the test, and then the test directory, test1. So it will give you the permissions here. Why are we doing ls-ld? Because we are just specifying the specific directory here. If you do ls-l, it will bring up everything in here, so we don't want that. So the reason I did here is so that we could go in there, try to go in there as a regular user. So exit as a root and go back as Zafar. And what you could do is, if you are a Zafar, right? What is Zafar right now? For this directory, he is other. So if he falls in this category, does he have execute permissions? Yes. So let me see, cd/test1, and I'm inside the directory cd test1. If you do ls, I could do ls also. So what I did was I'm able to get in there as into this directory as a regular user. Okay, everybody with me so far? I think everybody's quiet here. Everybody has a question, so let me go ahead and wait for a moment here and ask. So, what is the question you have now? So a regular user is able to get in there as a regular user is able to get in there, get in the directory, which by default is already have execute permissions for almost everybody here. So if you look at the directory, almost everybody could go in there in this directory here. So as a regular user, you can even go into, as a regular user, you can go into this home directory here, cd/home. Okay, now if you try to go into the directory of other users, like here Superman, Terminate and Zafar, they're not allowing anybody else to go in there. Only who could go in there? In this case, only Superman could go, or Terminate could go, or Zafar could go. If I am as a Zafar, if I try to go in here in this directory into Superman, the permission is denied because I don't have authority to go in those directories here. It makes sense, right? You're not, if you're sharing a computer, but you're not allowed to go into somebody else's directory. Okay, so let's go ahead and go back to as a root, sudosu hyphen, and you have to give the password for Zafar. So let's do ls hyphen ld /test1. Okay, remember we are playing around with the directory which is in the root directory, and the name of the directory is test. We are /test. If you do in a present working directory, if you do ls, that directory doesn't exist. The dir directory exists. Okay, test1 doesn't exist there. Okay, so now I think that's enough here. So let's work on the umask. So there is something which is built inside umask. Okay, so what is umask by default? Okay, so before that, let me go ahead and create a file here. You could type, so here if you do ls-l, the directory is there. Now I'm going to do touch file1, and if I do ls-l, so the default, so these two files are there. So let's go ahead and work on these two files. Why is this the default is coming here as different? So default system default so let me see, by default system provides 755 permissions to a directory folder, I should say, and by default system provides six four four permissions to file. So now type umask in the system, UMASK. So everybody should get 022. So I'll explain you what a umask is. Okay, so we have this number here, 022. What is this means here? So we have 0 here, 0, 2, and 2. So what is the umask for? So what is this position here, 022, right? It's giving you the permissions from 4-digit number, and we are seeing only 3-digit number here. So but anyway, don't look at this first 0 here. Look at this second 0 here, second, third, and fourth. So let's start with fourth here. What position is this in here? If this number is 2, okay, and is this part here, what position is this? The highlighted one, whose position is that? User, group, or others? Yeah, very good. Others. I'm going to put O. And whose position is this? Group. And this is the user. Okay, so what is happening here is so 022 is granted here. So when a file is created, the permissions are actually given 666. So when we look at this file here, default, this is default, right? We didn't change any permissions to this file. So why this is right now is 644 is the default permissions. 644 is file permission. So let me insert a table in here for so this part is users, group, others, and default. Okay, so what happens here is system provides system provided permission okay, and umask removes the permissions and then final default permission. Okay, so by default the system is providing 666 and default permission is 666, but at the same exact moment we have umask to deal with. Okay, so right now we're gonna deal with this part here. Umask, actually the first 0 is symbolic. Okay, so that means it's not being used here. Right now that 0 is not being used. So we are only dealing with these 3 parts here. So umask removes the permissions here. So for users, what is umask removing? What permissions is umask removing? Is it removing any permissions?
No.
So we'll put 0. And if you do the math, 6 minus 0 is 6. And over here it says umask to take out number 2 position, number 2 from here. So if we put here, so what is left? 6 minus 2 is how much?
4.
Okay. And then for others, it's taking out number 2 also. So 6 minus 4 is 4 here. So here, the umask is 022. And the final product is 644. This is what we have here, 644. Okay. So the default system, so when you create a file, system gives the permission 666, and at the same time, the fraction of a second, system removes the permissions 022, and then the final permissions is 644. Okay, system. So by default, file permissions are calculated using 666. That means 666 means it's only 7 number execute is never allowed. So 4 and 2 by default, the file permissions are given read and write, never execute. No matter what, execute is never being thought about in here. It's only being thought about from 666. Okay, by default, permissions are calculated using 666. Okay, let's look at the directory. So by default, can somebody guess by default which? So here, (755) is file permission, folder permission. Okay, so by default, folder permission are calculated using what number? Can somebody take a guess what number is being used out of?
777.
Yeah, very good. 777. So when you create a directory, it goes through the same process here, but instead of 6, it's going to go for read, write, execute permissions. So here is going to be out of 7, 7, 7. Let me delete all this here. Okay, so we mentioned here that everything is being calculated based on 7. So I'm going to put on 7 here, 7 here, 7 here, and default is 777. And now let's put in our default UMask. The UMask applies to everybody, the same, files and folders. So UMask is 022. 022. So our default UMask is 022. Okay, so if you do math here, 7 minus 0 is how much? 7.
7.
And 7 minus 2 is what? 5. 5. 755. Very good. So now you see 755 is the default permissions. So by default, the permissions is 755, and this is what it looks like. This is what it looks like. 755 equals this, and 644 equals this.
I have a question, Mr. Zafar.
Yeah.
What's the purpose of the system creating a different permission, and it has to now go back and remove the permission to finally get a default? Why doesn't it just go straight to default permission of 755 instead of having another step to get to that? I'm just confused about that. So
what you could do is the system is doing that because you could change this default 022. You could change it to anything else. So for example, if you're doing in a very high security environment like CIA or something, even CIA said, oh, execute permission. We don't want a regular user even going in there and looking at the files for the folders here. So they take out this position here. If you do 022, then the UMask will get going on it. So if you type umask 0022 20 and you type umask again, now if you create a new file here, it will be creating using this file here. Okay, so if I do touch file 1, file 1 is already there. If I do touch file 2, and what do you expect here? I think I messed up here. So if you want to take out only permissions for this user here, okay, so what you do is, let's do this here. So everybody set a umask 0000 and hit enter. And if I do touch file 2, so what is the permission you think the file will get?
777.
Yeah, very good. If you do ls-l, this file is getting 777, right? But why is this like this here? It's not giving you the full permission.
File was created before.
No, let me go ahead and remove everything. Umask is all 00s, right? Now I'm going to do touch file 1 and hit enter. I do ls-l. I was expecting everything to be 777, but what is this now? Can somebody read what is this now? 666. Why is this only 666? The answer lies here, right in front of you. Okay, what kind of file is this? Is this a file or folder?
It's a file.
Yeah. So the maximum, even the system cannot give 777 permission to the file. The maximum it gives is 666. So it did give the correct permissions based on the 000 umask. If you do mkdir folder 1, now you should have 777 permissions because the folder 1 is giving permissions based out of 777. So remember, the maximum permissions you could ever have for a file is 666 and the folder is 777. So note, maximum permission maximum permission if the umask is 000 is 666 for file, and it's 777 for the folder. Okay, you're not gonna you don't have to remember this too much. So the umask will be reset to its default once you reboot the system here, okay? If you don't reboot the system, the UMask stays the way it is. In fact, let's exit out of this and let me go back in there again to my, and then okay, so the UMask, if you exit out and come back in there, the UMask is come back to its default. There is a place you could change the UMask, but I'm not going to show you now. You don't have to worry about all that.
Zero two two is standard permission for
Yeah.
UMask?
022 is standard permissions for as a root user. There is a different permissions for the regular user too. If you go in as Zafar and you do UMask and the permission is 002. So but you're not a user. I'm not working as a user. If you work as a user, you don't have any permissions. You will be working mostly as a root. So you worried about only root here. In this scenario, what would be the permission for the file?
It would be 7
For the file.
664.
Very good. And the folder?
775.
Yeah, very good. So remember, whatever the number you see in the UMask, that is being taken away. All right, let's take a quick 15-minute break, and then we'll come back, and then we'll work on more exciting things here, okay? Okay, so we learned a lot today here about the permissions and the UMask. Okay, so now we're gonna go into a different territory. So all right, so let me clear this. I'm gonna go into as a root. Okay, so what I'm gonna do now is we talked about the users, right? Here's one thing here, the permissions and the user administration, they go both in hand, okay? So if you look at administration, you have we did some stuff in here, like we created the user, right? We did a user add, but we have not created a group. A group is automatically created. So what we're gonna do is we're gonna take a look at adding a group. Okay, so here what I'm gonna do is let's go ahead and add a group. So before that, everybody do a ID terminator. Everybody should have terminator in there, right? Can you guys hear me?
Yes, we can hear.
Okay. So if we do ID terminator, we get this information here. He's a part of a, so this is his user ID, this is his default group ID, and the groups he belonged to. He belonged to a group named terminator, which is this one here by default, and he also belonged to another group called wheel, which is a system administrator's group. Okay, so now let's talk about adding a group. So how do you add a group? We did a user. We did cat etc password. This will take a look at the users. And you do cat etc shadow. This will look at the passwords for the users here, okay? And now there is another file called cat etc group, and this holds the group information here. So don't get confused between Zafar and terminator. They are the users as well as they are the groups also. Okay, so now what we're going to do is we're going to add a group without creating a user. Okay, so what we're going to do is so let's take a look here. What is a group? Okay, so let me tell you what groups is. So groups in Linux, groups groups is a mechanism to manage a large collection of users and manage their permission. Okay, all Linux user have a user ID and as well as group ID is called GID, GID, okay, by default. So if we do a cat etc password, we have Zafar and we have terminators, right? So if you do ID Zafar, so by default he's already have a group, and on top of that we added him to another group here. This is just informational groups. That means he's part of these groups. If he had another group here, he will be part of another group that will show up in groups. It's group ID and user ID is by default there. So you do ID terminator, and he has an extra group which is called wheel. Okay, so let's work on creating a new group. So I'm going to create a group name. So to add a group, what is the so if you do ID terminator, right? So this is what you have in there. So let me explain you what I have put in up here. So Linux group. UID is user ID. Okay, and GID is group ID. And groups, it says group user belong to. Info about this user, other groups he belong to. Other group membership. He's a member of his own group, and he's also a member of which group he's a member of right now? He's also a member of Terminator, and he's a member of the group named Wheel. So here this part is him, Terminator. Okay, and GID is his default group. And this part is the groups he's part of. Okay, good.
Question.
Yeah.
Where does this wheel group come from?
What do you mean? Go into history. Yeah, if you go into history and grep for wheel, right here, right? Wheel. We manually added him to the wheel group.
Yeah, I remember that, but like,
This
who
is a
created the
default.
wheel group?
This is a system
Oh,
default group.
okay.
Yeah, that's a very good question. If somebody is in a wheel group, that means they could become administrators. They have a root access. That's what we normally say. So let's physically create a group. So I'm gonna create a group name. I'm gonna say group add. So to create a group, the command is group add. Okay, so let me go ahead and type the group name group add and hyphen G. That means it's a primary group. And then we're going to give the name of the group. So, well, we're going to give the group ID and the group name. So we are following up with the group ID. Group ID, let's do. Everybody has 1000, right? So let me give the group ID, the numerical ID, 9000, and the group name, I'm going to give it machine. Okay, now if you do cat etc groups, you should see in there. Cat etc group. So the group is machine, and it says here 9000 is the group ID. So what we did here is we added a group.
It has to be a 4-digit number only to assign a group?
Yeah. If you look at in here, it's we gave that randomly 9000. If you wouldn't have given the 9000, it would have picked the next number in the category. So you would have picked like 1001, right? It would have picked 1002. So we forcefully gave 9000 here so that for our purpose. Okay, so what happened here is the group is so the command is group ID, group add, and this one is -G, and this is 9000, and this is machine. So group add is a command. It's just a built-in command here. There's nothing you can do about it. Okay, and -G means this is a primary group. And this is GID, G-I-D, that means group ID. And machine is a group name. Okay, that's all there is to it, nothing else. Okay, now what I'm going to do is I'm going to clear this. So now what we'll do is we'll put Terminator into machine group. I do ID Terminator. He's in the group machine group. He's not in machine group yet. So what I'm going to do is I'm going to do user mod. We're going to use our good old command earlier we used, user mod -ag. That means add group. Okay, if it's a capital group G, that means it's a secondary group. Okay, then we're gonna say 9,000. We could give the group ID or we could give the group name. Machine, and who are we gonna grant it to the group? Terminator. So if you do ID Terminator, now he should have a third group now. Now he's a part of 3 groups. He's a part of group Terminator, he's a part of group wheel, and he's a part of group machine.
So with that command, mine did not add it. It didn't add it to the group Terminator.
No, we're not adding Terminator. We are using, well, if you have deleted it, add user add Terminator. Just type that command.
No, I'm saying like when I did the mod for Terminator to be added into the machine group, it's not doing it.
So you type user mod -ag. Did you create the machine group? Did you
Yes,
do
sir.
user add machine 9,000 machine?
Yeah, I created group add AG machine, and I did that already. So I'm trying to add Terminator to the group machine.
Okay,
and when I did the command,
first do ID Terminator and see what happens.
yeah, it got a return UID 1001 Terminator.
Okay.
Group ID 1000.
So now type exactly like this. User mod hyphen space hyphen A uppercase G, and then you give the machine, or you could type the ID also. Instead of machine, you could type 9,000 if you have used 9,000, and then this is the username Terminator.
Okay, yeah, I think that's the part that I was missing. That's it.
Okay, now if you do ID Terminator, he should be part of 3 groups now, because one is a default. This is the one we added earlier, and this is the brand new group he's part of now, because Terminator, he's a machine from the future, so he's a part of a machine group. Okay, so now let me explain you what this is. I think I already explained this, didn't I? Okay, I just showed you, but I didn't explain you because I was going to explain you now. So now what I'm going to do is I'm going to explain you how this worked here. So let me have okay, so this is user mod -ag, and this is the group name is 9000, right? We did machine, and this is a terminator. So this so user mod is what is user mod is nothing but a command. Okay guys, anytime you are seeing the uppercase and all that, just assume it's a lowercase, okay? Okay, -a means add, and hyphen uppercase G means it's a secondary group. If you do lowercase g, then he will show in here. It will change. This will change to primary group, which would be machine. But we normally you don't use that as much. And this is git group ID, or you could use the name also. If this was group ID, what is my group ID here for machine? I could, instead of typing in machine here, I could type the number also and the user ID. Or if you could go back in here, and if you do lowercase g, that will become his primary. Okay. Okay, so you don't have to use A, just use G. So user mod -g means it will automatically take it as a primary group. So if you do ID terminator, see it removed 101 and it made it as a primary group as 9000.
Have you ever thought of what it feels like to run a 400-acre farm? Well, today I'm here to make your imaginations a reality, because that's just what I'm doing. Now, running a 400-acre farm and living on a farm simply means that you don't have the luxury of recording a video from a place with very nice lighting. So it's super bright. Okay? It is so bright.
Can you go on mute, please?
Yes, a lot of wind.
All right, thank you. All right, so now you see the difference here, right? We changed the user mod -g, and this -g, what it did, it set it as a primary group. Okay, now let's play around with this. Now what I'm going to do is let's do ls hyphen ld / test, right? Let's create a brand new folder here. Create a new folder and we'll work on that. So do here mkdir, and we're going to create a directory into the root directory / and then give it a name assignment. Give it a name assignment, ASSIGNMENT. Okay, so the terminator got assignment, and then let's go into that cd into assignment and ls, and go in here and create a file. So go in here and go vi terminate. What's the kid name he came to terminate in Terminator? Anybody remember? All right, let me look it up.
We can use Sarah Connor.
Okay, Terminator Sarah. And so we go like in here, terminate Sarah Connor. And let's do John too. Now I just remember it, John Connor, right? And in here, give terminate. Okay, now let's switch as a, before that, let me copy all this here. The reason I copied in root here is nobody would have access to root directory. A user could come in and root directory and then do this here. Since we are working this off as a root, let's keep this outside the root directory, okay? Because root directory is much more secure. If you do ls-ld /root, it's much more secure compared to other directories here. So let me copy this part here. Create new folder and files. Okay, so we created new folder and then we created two files in there, terminate Sarah and terminate John Connor. And let's look at the permissions. ls-ld assignment. Okay, these are the permissions, and then do ls-l assignments, and it gives you the permissions here for the user, the content. Okay, ls-ld, it gives you the permission of the directory itself. And ls-l and the directory, it gives the output of the content of the directory. Okay, you guys gonna need to remember that. Permissions of directory and okay, so this is okay, this one gives you the permissions inside the directory. We are running this command outside the directory, not being inside the directory, okay? Okay, so we're gonna now this is gonna get really interesting here, okay? So let me clear this. Don't worry about this if this is too much. I'm giving you each and every piece of this, and assignment will be what we have here. I will walk you through each and every steps here, okay? So don't worry about all this here. Okay, so we created a directory and we assign all this here. So this looks good. Okay, now what we're gonna do is we're gonna give our terminator access to this directory. So let's go ahead and go into as su terminator. Terminator. And who am I? If you do cd pwd who am I? Okay, he is a terminator. If you do ls-ld as terminator to assignment, okay, so if you see the execute permission here, anybody could go in there. So terminator should be able to go into this assignment directory. And if he does ll here, so let's see if he is able to go into the file here. So if you could do cat terminator John, terminate John. So he is able to read it. But can he execute the directory or can he write into the directory? If you do vi terminate John, so he's able to, since he's able to read it, but he's not able to write to it because it says on the down at the bottom it's read only. So vi, just doing the vi part, that doesn't mean he could write it, okay? He could also go in there, but he cannot go in there and say mission accomplished, right? And if you try to save and exit, he's not able to do that because he doesn't have that authority. So let's grant him some permissions. So get out of there. Actually, let's open another window here. I'm going to open another window, duplicate session, and I'm going to log in to the master. From there, I'm going to log into my other host. So I'm going to log in as Zafar. I'm going to put in my secret password. Okay, I'm logged in. Now what I'm going to do is what is my system number here? I think 117, yeah. I'm able to log in as a without password because passwordless is set up. I'm gonna switch to root.
Do you want to do you want us to log into the second server or still the first one?
Still the first one. Come back in there because we're gonna keep two windows, one as a terminator, one as a root. Okay, because we'll be going back and forth on the permissions. So I'm a terminator here. Right, so what I'm going to do is first go ahead and remove the guru. I'm going to do ls-ld assignment. So what I'm going to do is I'm going to remove the I will remove the read and execute permission to everybody for this folder. I'm going to do remove read and execute for groups and others. So what would be the number? chmod, and I'm going to remove the permissions to everybody else. So what I'm going to do is, okay, what would be this part here? This part is remaining the same. So what would be the number? What is read? No, for folder. This is folder. So what is read, write, execute? What is the total number? 7. And then I want this 0 and I want this 0. So what would the number? 0, 0. And I'm going to give it to assignment. And if I do chmod, if I do ls-ld assignment, now you see a weird here. So our terminator, if he try to go into cd assignment, he should get access denied. See, permission denied. Why is the permission denied? Because the group part doesn't have permissions and other part doesn't have permissions. So if you did ls- try to go in there, he doesn't have permissions in there. So what we're going to do is we're going to give permissions to, we're going to give the we're gonna give the ownership permission to machine group. Let's do ID. So I'm not gonna give directly permission to him. I'm gonna give the permission to the machine group. If the machine group has permissions, then he should be able to go in there also. So they give the ownership permissions, chown -r, that means recursively, and then this is root is the owner, and group owner is going to be machine, and the assignment folder. Okay, so what is going to happen here is so this part is chown. This is the new command we are learning. Command and this part recursive means everything inside that folder. Recursive, I think I explained you, right? Recursive means everything inside. This, in this scenario, everything inside. And then who's the group? We could change the ownership also, but I'll explain that later. Right now we are keeping the ownership as is, root user. And this is group user. Okay, so once I hit enter here, and if I do ls-ld, you see here that the machine has the ownership into it. Even though you're not going to see it here, he should be able to get in there. Let's see if he's able to get into CD assignment. Oh, okay, so he's the owner here. He should be able to get in there. Let me exit out of there. And let me go back in there as here. CD assignment. The permission is denied. Okay, now I know that even though he has full permission here, full access here as machine, and he belongs to machine group, but he still needs the permission for that folder here. Okay, so what I'm going to do is, before that, let me copy this part. Okay, now what I'm going to do is I'm going to give others permission or the group's permission. chmod. I'm going to keep the same permission as is, and I'm going to give the others permission. I'm sorry, not the others, group permission, full permission. So what should I do? Full permission is 7-0. Okay, and I'm giving it to assignment. Okay, so the permission the permission still needed to be granted. Okay, just because he's part of this, that doesn't mean he's have a permission to that. Okay, so now what I'm going to do is I'm going to give the full permission here, chmod 770, and if I do ls-ld, he has a root, read, write, and execute permissions here. So let's try again. CD per assignments, and he's able to get in there. And if you do ls-l, he is able to go in there as so he has those permissions there, right? He is able to read and write here. What about the execute permission? Over here, we assigned this permissions here only to the assignment group. Okay, and if you do that here, so he is able to get in there. But we need to give him the read and execute permissions for the files also. Okay, so what happens now? Before that, let's switch to Zafar here and see if Zafar is able to get into the directory. So Zafar, he need to be part of the machine group for him to be able to get in there. He's not. So let's see if he's able to get in there. CD/assignment. and his permission is denied. Anybody who is in the group machine is going to go in there. So we're going to create T2000, T2, Terminator 2. We're going to create him and try to send him in this here without doing much and just putting him in the group machine, and he should be able to get in here. Okay. So now here, if you do ls-ld, here these are the permissions that he's seeing. Now what I'm going to do is he still doesn't have the permissions for the group. So I mean, if the content, the inside this file, he could read it, but he cannot write to that file here. So what we're going to do is we're going to give the similar permissions, but we will do recursively. So I'm bringing up here the same exact command. Oh, let me bring up same exact command here. I'm gonna give hyphen uppercase R. Okay. So now if you do ls-l, so the machine group has full permissions here. Read, write, execute, read, write, execute. Okay, so now what we're gonna do is we're gonna go into vi terminate Sarah. And here it doesn't say read only permissions. It's gonna say mission impossible. She got away. Okay, done. So Terminator is done now. So now what we're gonna have is we're gonna send another Terminator to take out John. So everybody use user add T2. Okay, and hit enter. And you do ID T2. Normally all the IDs doesn't have any uppercase here. I'm just putting in here so that you have a better visual here. T2 is there. The user T2 is there. Let's put this user T2 into the group. So we're gonna add him user mod hyphen AG, or we'll just give G. Machine, and what is the number we gave here? This time I'm going to give the number 9000, and who are we giving the assignment to? T2. Okay, if you do ID T2, he is a part of a machine group now. He is more lethal this time. Okay, so he's gonna come here to protect John actually. So before that, let me go ahead and copy this. So we gave him recursively -r means -r. This will change the folder as well as content inside the folder. -r, this will change the permissions for folder as well as the content inside the folder. That should be clear enough here. So we did 770 and these two files has 770 in it. And what we did is we went ahead and add another user. Okay, now set the password also. Password T2. Let's give red hat. Okay, he's all there. So now I'm gonna exit here and I'm gonna do su T2. Okay, so now what I'm gonna do is I'm gonna just put this part also password. So now he did this Terminator 2 is back here. Now his mission is to protect John. Okay, now he's gonna go into his assignment group and he do ls-l. By the way, LL works the same thing too. If you do double L, it gives you the same information. Okay, so now he has a. Okay, so let's change this name to. Let's give this name Save John. Okay, instead of Terminate John. I hope there. Okay. Now T2 is there. His assignment is to save John. So he's going to go into vi save John and he's going to open new file here. And he said mission accomplished. Okay, so what I'm saying here is you're going into VI and changing the file, even though he's not the file owner. Look at it here. The file owner is root and the group owner is machine. Since John is a part of a group, he's able to do whatever the group has permissions to it. So to demonstrate that, So let's do, I'm going to create another user T9000. I'm going to do a user add T9000, right? There is T9000 also that came to kill him. And password T9000. And we do ID T9000. Okay, he's not even, he came in to kill him, but he's not part of a machine group. So let's see if he's able to do any damage at all. So he's a part of a machine group and he's able to carry out his task. Read, write, and execute. So we added him in here, and I'm going to exit here, and I'm going to SU T9000, and I'm going to clear the screen. Who am I? And T9000. I'm going to go into CD/assignment. He can't even get in there, let alone reading the file here. Okay. I hope that this makes sense here. You know how you could add him. The moment I put him in the group, boom, he is able to do whatever task he wants. So long story short, if you have like 1,000 users and you need to give 1,000 users access to one particular folder, right? You're not going to go and give that 1,000 users access to all those files here. What you're going to do is you're going to go and give access to the group. Boom, they will have, all of them will have the access to the access to that file or whatever you're trying to give access to. Okay, so now permission denied. Okay, any questions so far? Let's take let me just continue for another 5 minutes and then we'll wrap this up. Okay, so now what I'm going to show you is another 5 minutes. Permissions using letters. Okay, so what happened here is you could also use, I'm gonna just exit out of here. Okay, I'm gonna clear ls-l. So there are things that you could give the permissions using the letters here, right? I'll show you in a minute here. So what happens here is, let me create one table here. So what this is ID. So what is this? User. And user is represented with lowercase u. I think I already told you G is represented for group, and others is represented with O. Okay, lowercase o. And everybody in the group is represented with A. Okay. And let me copy same thing here. Everybody agrees with me, right? What I have in here. So here the permissions. Okay, read is represented with R and the number is 4. I'm just showing you this one more time. Okay, is 4. Write is W. What is the value for write? Anybody? Value for write is 2 and execute is 1. Execute is represented with X, okay, not E over here. Okay, and the actions. Okay, if you do plus, that means you're adding permission. If you do minus, remove permission. Okay, and make it only permission. What is it make it only permission? Equal to. Okay, so let me go ahead and clear this. If I do ls-l, I have file here, right? So what I'm gonna do is chmod, okay, and I'm gonna remove the permission. Let's do chmod 000 file 1. It doesn't have any permissions. Okay, I want to add only permissions to user. Chmod. Now I'm going to do plus. And who am I adding the permission to? User. Okay, and then I'm going to say A equal A. What? So I think I have to do user plus A. Still doesn't work. Okay, it may not work this way here. So if I do ll here, right, what I'm gonna do is I'm gonna do chmod u plus rwx and the file name. See, what I did was I used, instead of using the numbers, I used u is user group, and what kind of permissions you have? Read, write, execute. Okay, so what else I could do is I could do group, and group need read and write execute, not everything. So if I do ll, and you see the group has different executes permissions here. Let me get rid of folder here. I'll refresh this again tomorrow, don't worry. Okay, so we started with 0 permissions here, and I did so this is not there either. So I did this permission u plus read, write, execute. So what happened when you do it, the group, the user has read, write, execute permissions, and this time we are giving only group read and execute permissions here. Okay, and this one came true for this user group. Okay, so this is it for today. I'm gonna stop here, and then we'll pick up tomorrow, and then hopefully this is getting interesting. And don't worry, it looks daunting here, but it is not. It is very, very easy. I will probably give you some exercises that will help you very much. Okay, if you have any questions, go ahead and put in group. If not, we'll meet tomorrow and then we'll finish this up tomorrow, and then the following week we'll start working on disk management. Okay, if you have any questions, put in a group, please, or contact me directly. All right, no questions means I'm going to end here, and I will catch up tomorrow. Everybody have a good week. Good day.